Assalamu alaikum everyone. How are you guys? Good evening. I'm good, alhamdulillah. Hello, sir. I'm soon about to start AS A level, but I'm confused whether to take maths or not. So I'd love your advice regarding this. See, if you are genuinely passionate about maths, then definitely I would recommend that you take maths. Also, if it's a requirement, whatever it is that you want to do in the future, you want to pursue a certain degree where math is required, if that's the case, then obviously you have no choice. But if, let's say, the degree that you are pursuing that doesn't really have math as a requirement, then what it really boils down to is whether you're genuinely into math or not. So if you are one of those who are genuinely into math, only then will I suggest that you pursue math. Otherwise, life is already quite miserable without math, so why make it more miserable than it already is? But the thing about math, jokes apart, the thing about math is that it's one of those subjects that can only help you, okay, if you do well. If you don't do well, it's a double-edged sword basically. If you don't do well, and you have to spend a lot of time to do well in it, then what happens is that the time that you spend doing well in math, you could spend that time on other subjects, so you end up compromising other subjects. So yeah, that's about it. एड मैथ्स इंशाल्लाह कमिंग वीक में. सो ये वीक में अभी क्या है हमारे पास, थर्सडे है, फ्राइडे को भी एक स्ट्रीम है. So maybe Saturday, Sunday, I'll do a stream on AdMaths also. I'll announce on my Instagram. Okay. Anyway, so let's start. So should we be doing yearlies right now or focus on improving topicals? Yearlies should be a main priority, and through yearlies, you should be able to identify your weak areas, and then you should focus on your weak areas. You should focus on those topics that you're struggling with. So at this point, with very little time, you guys should be solving yearly past papers as much as you can on your own. Okay, so today's agenda is to start and finish binomial distribution. Yes, I will do P1 past papers live stream, inshallah, and that will start from the first week of April. Okay. So, as I was saying, today's agenda is that we are going to cover binomial distribution. We're going to do both the concepts as well as past paper questions. So let's write down today's date, the 6th of March, 2025. Now, basically, the whole idea behind binomial distribution, normal distribution, and geometric distribution, what's the whole idea behind doing all this? As in, why do we do this? There's one purpose and one purpose only. And what's that? So we have binomial, we have geometric, and we have normal. These are the three distributions that we have in our syllabus. And the agenda behind using them is the same. And what's the reason? What's the objective behind using these three distributions? We use them for one purpose and one purpose only, and that purpose is to find probability. Okay, so these three distributions are used for one purpose, and that purpose is to basically find the probability. And by the way, there are two worksheets that you guys will find. There's a link in description, and you can download the link. You can download the two worksheets, keep a copy of them. Yes, this will be posted. This will inshallah be posted, so you can watch it later also if you want. So I've done around 12 to 15 yearly so far after good topical practice of each topic, but I often get stuck. Some tricky questions. No, that's not alarming. That's not alarming. If you've done 12 to 15 years so far, then keep solving yearly past papers. This is something that you can improve gradually. Okay, but don't do a lot of back and forth. Once you start yearlies, you should be focusing on yearlies, and the tricky ones, the topics that you find yourself struggling in, for that you can do topical past papers. Okay. Now I forgot to mention that those of you who are watching, if you can just like the stream and also subscribe to the channel if you haven't done that already, I would really appreciate that. Now, what are when do we apply binomial distribution? So we know that we have three distributions, binomial, geometric, and normal. So when do we apply binomial distribution? Let's talk about that. So what are the conditions to apply binomial distribution? So can we just look at a question and decide that we have to apply binomial distribution? No. There are some conditions upon which we decide whether we should apply binomial distribution, normal distribution, or geometric distribution. So the first condition is that there are a fixed number of trials. Now, fixed number of trials means that maybe 5 objects are drawn at random, or maybe 10 days are selected, or maybe 10 people are selected. Okay, so when it says fixed number of trials, so look for something like this, where the question says that maybe 5 objects are drawn at random. So that means the number of trials are fixed, and that's 5. Okay, it doesn't necessarily have to be 5. It could be, let's say you're selecting people, and the question says that 10 people are selected at random. 10 people are selected at random. Okay, and maybe the question might say that, 15 days are selected at random. Okay, so look for a fixed number of trials, and if you find that, that means the question belongs to binomial distribution. And condition number two is that there must be only 2 possible outcomes. There must be only 2 possible outcomes. Now, 2 possible outcomes, what does that mean? And if the outcomes are more than 2, then what we do is we group them into 2. So what do I mean by that? Here's what I mean by that. So an important note. So we're going to do theory first, and then we're going to move to past paper questions. So if let's say there are more than 2 outcomes, then we group them into 2. Okay, so if there are more than 2 outcomes, we group them into 2. Now, what does that mean? I'll explain. So let's say you're playing a game. Okay, 2 people are playing a game. So there are 3 possibilities. Okay, you could win, you could lose, or there could be a draw. Now, how do we group this into 2 outcomes? So we say winning is 1 outcome, okay, and lose or draw is the second outcome. So this is the second outcome, and this is the first outcome. Okay, so that's one way to group them into 2. If let's say there's red, blue, green, okay, and we're interested in red. So if you're interested in red is 1 outcome, and everything that's not red is the other outcome. Okay, so we group them into 2. If let's say you will often find questions where we're talking about whether you're early, on time, or late. So if let's say early is what you're interested in, so early is 1 outcome, then everything else, whether it's late or on time, is the second outcome. Okay, so that's what we do. Okay, now let me take some questions, sir. I know nothing about S1 binomial distribution, so that's okay. You're in the right place. You'll find out how it works. Sir, my preparation is only around 10%. Can I turn things around? Yeah, you can. I mean, people usually wake up towards the end. So you can turn things around if you stop talking about it and you actually start doing something. So it's possible. Now, each outcome must be independent, meaning that it should not be dependent on the other. Okay, so that's condition number 3. Okay, and condition number 4, now we're getting into the rules. Okay, so condition number 4 is that probability of one event should not affect the probability of the other. You know, when we're talking about with replacement, in those questions, probability of one event affects the probability of the other. So that should not be the case. Okay. Rule number 5, and that is the probability of favorable outcome, which is P. Okay, probability of favorable outcome, which is P, and unfavorable outcome, which is Q. Should be fixed. Okay, that means it should not change. Now, P plus Q is equals to 1, meaning the probability of favorable outcome plus the probability of unfavorable outcome is equal to 1. Okay. Number 7 is that the number of trials must not be more than 30. Okay, so you should not have more than 30 trials. If the number of trials are more than 30, what we do is we convert it into normal distribution. So we're going to learn how to do that. Okay, so we're going to learn how to do that later on. Okay, now, sir, is it possible to cover the entire syllabus in a month? If you're talking about M1, S1, it's possible. If you're talking about P1 or P3, then honestly speaking, it's not. In that case, it's not. Achha. How many questions should we do for each chapter? Enough to cover all the concepts that can be tested. Sir, is y minus y1 equals to mx minus x1 formula? No, it's not allowed in math. It's not allowed in math. Okay. So, now we're starting some generalization. So, x has a binomial distribution. This is how we write binomial distribution, where n is the number of trials and p is the probability of favorable outcomes. Okay, so this means that a variable has or follows the binomial distribution. So this symbol that you see basically means has the distribution. That means the variable follows binomial distribution, which means that it follows all these rules. Okay, now these are just formalities that we have to go over. And then once we start solving past paper questions, this is not something that you will have to worry about. Now, what's the formula? The formula is NCR, P raised to the power of R, and Q raised to the power of N minus R. Now, this formula is slightly different than the binomial formula that we use in P1. Okay, so be careful. This formula is slightly different compared to the one that we use in P1. Okay. Now, what's N? N is basically the number of fixed trials. Okay, N is basically the number of fixed trials. P, as we know, is the probability of favorable outcome. And Q, as we know, is also the probability, but it's the probability of unfavorable outcome. Okay, and what about R? R is basically the number of favorable outcomes. And what could be the range of R? It's from 0 to n. Now, if this doesn't make total sense, there's nothing to worry about. When I solve a few example questions, you will notice that it's actually not that difficult. Binomial, honestly speaking, is one of the easiest chapters of S1. They're one of the easiest chapters of S1. Acha, now I'll take a few questions. I don't teach S2. Sorry, I don't teach S2. I'm not sure, but I think Sir Zain teaches S2, so you can check out his channel. You might find some content there, but I'm not too sure. Achha, what else, sir? How many yearlies should we do in a day leading up to the P1 CIE? I think you should be doing a minimum of at least 1 or 2 yearly past papers every day. Okay, if you've completed the syllabus, that's what you should be doing. Thank you so much. I appreciate that. You're welcome, Misha. Yes, I will be. Every live session that I do is uploaded immediately. Okay. Now, what we're going to do is we're going to solve a past paper question. And we're going to solve plenty of past paper questions. So let's see. Here we go. Here is one question. Let's solve this together. Sir Zain, doesn't teach S2. Ooh, okay. That's the thing about S2. You don't. It's a great subject. I recommend students to take S2, but the only reason why I don't recommend them to take S2 is because of lack of resources. Otherwise, I think it's a phenomenal subject. It's actually more practical than M1. M1, honestly speaking, is not that practical, and it's difficult also. So I recommend students to take S2, but the only problem is that there aren't a lot of resources for S2. Any online YouTube channel for physics A level? I don't know, but if there's anyone else who would like to suggest, please feel free to do that. Anyway, so here's a question which we're going to solve. It's a past paper question. And the first part has a bit of theory. So in S1, you can always expect a bit of theory, some stuff like which is the better statistical diagram, stuff like that, or we are asked to comment on the data. So you can always expect something of that sort. Now, state two conditions which must be satisfied for a situation to be modeled by a binomial distribution. So we know the two conditions, okay? We know, in fact, so many conditions. We just have to write any two of them. So we can say fixed number of trials, that's one. Fixed number of trials, that's one. And condition number two is that there are only two outcomes, or you can say that the probabilities of favorable and unfavorable outcome should be fixed. Okay, so it's up to you. There are so many conditions that we know. We just have to write any two of them. Okay, now part two. Part two is the meat of the question. It says, in a certain village, 28% of all cars are made by Ford. Okay. 14 cars are chosen at random in this village. Find the probability that fewer than 4 of these cars are made by Ford. Okay, so let's write down the information. So 28%, so what are we interested in? We're interested in Ford. Okay, so we're interested in the cars made by Ford, and what's the probability that a car is made by Ford? That is 0.28. So this is basically our probability of favorable outcome, which means naturally the probability of unfavorable outcome becomes 1 minus 0.28, which is equal to 0.72. Now what's that? That is basically unfavorable. What's this representing? This is basically representing not Ford. Whether that's Ferrari, whether that's Toyota, whether that's Honda, it doesn't matter. So it's either Ford or not Ford. That's it. Now, how many cars are we choosing at random? The number of cars that we're choosing at random are 14. Okay, so n is equals to 14. And the question says fewer than 4. Now, there are some rules that we're going to write down. Okay, we're going to write them down later on. But fewer than 4 basically means that R could be 3, R could be 2, it could be 1, it could be 0. So basically, a nicer way of writing this would be that we start with 0. We go in ascending order. So 0 cars are made by Ford, 1 car is made by Ford, 2 cars are made by Ford, 3 cars are made by Ford. Okay, so this basically means that we want to find out the probability that x equals to 0. That means 0 cars are made by Ford. The probability that x equals to 1, which means 1 car is made by Ford. The probability that x equals to 2, which means 2 cars are made by Ford. And finally, the probability x equals to 3, which means that 3 cars are made by Ford. Okay, so how do we do this? This is not something that you have to do every single time. This was just to explain the concept. Now, what you should do every single time is as follows. So remember the formula? Let's write down the formula. Here it is. So we're doing this because we're doing it for the first time. Let's write it over here. In fact, let's squeeze it over here. Okay, now, so pay close attention. So 0 cars are chosen by Ford. What's the probability for that? 14C0, probability of favorable outcome, which is that a car is made by Ford, raised to the power of 0. Why? Because we want the probability that 0 cars are made by Ford. And the probability that a car is not made by Ford, raised to the power of 14, because if out of 14, 0 cars are made by Ford, that means all 14 cars are actually made not by Ford. Okay, so that is probability that 0 cars are made by Ford. Then 14C1, 0.28, which is the probability that a car is made by Ford raised to the power of 1. Why? Because we want 1 car which is made by Ford multiplied by 0.72 raised to the power of 13, which means that the remaining 13 cars are not made by Ford. Plus 14C2, 0.28 raised to the power of 2, 0.72 raised to the power of 12. So what's this for? This is to find the probability that 2 cars are made by Ford out of the 14. Then 14C3, 0.28 raised to the power of 3, 0.72 raised to the power of 11. What's this for? This is to find out the probability that 3 cars are made by Ford. Now, should we consider 4 cars made by Ford? No. The question clearly says that fewer than 4 of the cars are made by Ford. Okay, so we've considered all possibilities. Now what we have to do is we have to put this in the calculator and find out the probability. Achha, when you're plugging this in the calculator, what you should do is you should make a bracket around 14C1, 14C2, 14C0, and 14C3 also. Okay, so you should make a bracket around this also, and then enter it in your calculator. Now I'll show you how you're supposed to enter it in your calculator. And remember, when it comes to S1, timing is always an issue. Okay, a lot of students, you will notice, struggle with not the concept, but struggle with completing the paper in time. So in order to make sure that timing is not an issue for you, just make sure that you have a good grip on your calculator. Okay, I've seen a lot of students go crazy just because they don't have a good grip on their calculator. Acha, what's that? So are your worksheets? Okay, so we have to sit through an ad before the app opens. Acha. Okay, what's that? So are your worksheets enough for topical practice for each topic? Because there are a lot of questions. Sir Zain's worksheet has come. Dekho, my worksheets are bare minimum. Okay, my worksheets are the worksheets that I give to students as homework, and then I tell them to keep practicing from topical past papers. So my worksheets is the bare minimum that you must do. Okay, it's by no means a worksheet where I can say that if you do this, then that's an A star is guaranteed. It's the bare minimum. This stream is probably going to last 2 hours. So let's enter this. Let's work it out. Yes, it will be uploaded. Every stream is uploaded. 14C0, close the bracket, 0.28 raised to the power of 0. Now you could totally skip this because 0.28 raised to the power of 0 is as good as 1. So you might have skipped this, but let's not do that. Let's actually learn how to enter this in our calculator as it is. 0.72 raised to the power of 14. Plus, and you must enter it as it is. Okay, and it's important that you make a bracket for 14C0, C1, C2, C3. So 14C1, let's close the bracket, let's open the bracket again, 0.28, let's close the bracket, raise it to the power of 1. This also, you could have totally skipped because you could skip 0.21 raised to the power of 1 because it's as good as 0.28. And then 0.72 raised to the power of 13. Okay, so plus another bracket, 14C2, close the bracket, open the bracket, 0.28, close the bracket, square it, move it to the side, 0.72, close the bracket, raise it to the power of 12, then move it to the side, 14C3, 0.28, close the bracket, raise it to the power of 3, move it to the side, close the bracket, 0.72, raise to the power of 11. Press the equals to sign. Okay, इसका मतलब है हमने कहीं पे bracket नहीं लगाया. हाँ, यहाँ पे हमने bracket नहीं लगाया. So 14C3 के around bracket लगाते हैं. Now press the equals to sign. This is what we get. Correct to 3 significant figures. What's the answer? 0.419. Okay, so that's the answer. Now, we have gotten the right answer, but I want you guys to understand what exactly is the purpose of binomial distribution. The whole purpose of binomial distribution is, yes, to find probability, but what is this 14C1 for, 14C2 for? Okay, what's this for? So my calculator turns automatically to degree mode. Is that when you reset it, by default, it's supposed to be in degree mode. Okay, when you reset it, by default, it's supposed to be in degree mode. So I was explaining what's the whole purpose of using binomial distribution. Now, remember you're selecting 14 cars. Okay, you're selecting 14 cars and you want one to be made by Ford. So that means one car is made by Ford and the remaining 13 cars are not made by Ford. Now, can we not work this out without using binomial distribution? Of course we can. So if you've done probability, you know that we can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so here you can see that one car is made by Ford and the remaining 13 cars are not made by Ford. So this is one way that of the 14 cars, one is made by Ford and 13 is not made by Ford. If let's say this was probability, what you would do is this. You would do 0.28 because that's the probability that a car is made by Ford, multiplied by 0.72, the probability raised to the power of 13, because that's the probability that a car is not made by Ford. And then now you have to consider, because you're selecting 14 at random, you have to consider different arrangements also. So how would you consider different arrangements? You would do 14 factorial divided by 13 factorial, because there are 13 elements that happen to be the same. So for example, if I ask you how many different ways can you arrange these letters, you would do 14 factorial because there are a total of 14 letters, and divide by 13 factorial because you have 13 letters that are being repeated. So this is exactly what binomial does. 14 factorial divided by 13 factorial is basically what 14C1 really is. It's basically as good as 14. So this is the reason behind using binomial distribution. It's something that's good to know, but if you don't, that's perfectly all right. But if you do, it only strengthens your concept. Okay? Now, let's move on to the next question. So I'll take a few questions now. During calculation, it turns into degree mode. Okay, that's a first. Which brand is it, and are you sure it's original? That's the first. During calculation, it turns from radian to degree. That's definitely a first. Sir, is the P1 syllabus on your channel complete? You have all the important chapters, like you have differentiation, you have integration, you have binomial, circular measure, APGP, functions, trigonometry. Yeah, I think it is complete. It's as good as complete. Acha. Sir, I started S1 now, I have 6 chapters. Yeah, you see, S1 is something that can be done in 2 months. Okay, S1. And if, let's say, you give it a lot of time, you can actually do it in 1 month also. All right, I appreciate that. I recommend anyone who's doing. Can we have hard circle question stream? Okay, we'll have that later. I plan on, well, I am streaming often, but I plan on increasing the frequency the closer we get to exams. So let's solve the first part. A manufacturer makes 2 sizes of elastic bands, large and small. 40% of the bands produced are large bands, 60% are small bands. Assuming that each pack of these elastic bands contains a random selection, calculate the probability that in a pack containing 20 bands, so here we have n which is equal to 20, there are equal number of large and equal number of small bands. Now, if n is equals to 20, sorry, not 10, n is equals to 20, we want equal small and equal large bands. So if let's say we take the probability of small to be p, the fable outcome, that means q, which is large, is 0.4. Now the question is not specifying as to which should be the fable outcome. It says equal number of large bands and equal number of small bands. That means the large bands should be 10 and small should also be 10. Okay, large and small both should be equal to 10. So how do we do that? Very simple. 20, if large should be 10, so automatically small will also be 10. So, okay, because if out of 20, 10 are large, then the remaining 10 can only be small. So 20C10, 0.6 raised to the power of 10, 0.4 raised to the power of 10. And even if you change the order, it still doesn't make any difference. Okay, even if you change the order, it still doesn't make any difference. And if you work this out, you will get the probability that there are an equal number of large and equal number of small bands. So 20C10, 0.6 raised to the power of 10, 0.4 raised to the power of 10. So we get, let's see, what do we get? 0.117. 0.117 is the answer to the first part. Why 20C? Why would I do 20C20? 20C20 means that all 20 of them are large bands. The question says that equal number of large and small bands. Okay, equal number of large and small bands. Okay, so 40% are large, 60% are small. That's the probability. Probability of small is 0.6, probability of large is 0.4. All right, now part 2. Part 2 says more than 17 small bands. So now n is 20, the probability of the fable outcome. So small is the fable outcome and the probability of it is 0.6, which naturally means that the unfable outcome's probability is 0.4. Now what does more than 17 mean? More than 17 means that R could be 18, R could be 19, R could be 20. So that means we need to find out the probability that x equals to 18 plus the probability that x equals to 19 plus the probability that x equals to 20. That means there are 18 small bands, 19 small bands, 20 small bands out of the 20. So let's work it out. 20C18, 0.6, the probability of small bands raised to the power of 18, 0.4 raised to the power of 2, okay, plus 20C19, 0.6 raised to the power of 19, which means there are 19 small bands, 0.4 raised to the power of 1, which means there is only one of the other, which is a large band. And then 20C20, 0.6 raised to the power of 20, 0.4 raised to the power of 0, which means out of the 20, all 20 of them are large bands. Now, I do not recommend that you work these out independently. I recommend that you work them out directly using your calculator and you write down the final answer. That's what I recommend. Okay, so if you work this out, I'm just going to write down the final answer to save some time. You will get 0.00361. And I will encourage you to use your calculator and check whether you're getting the right answer or not, so that if there's a problem, we can fix it there and then. Okay, I will take your questions now. Sir, we have to go through random variable. No, you don't have to go through random variable. For this, you don't have to know discrete random variable for binomial distribution. You can do it independently. Do we have meanest questions PDF? Yeah, I am working on it. We'll have it inshallah out this month. Should I get past papers in hard form or just soft form? You should definitely get a hard copy and you should practice it on a hard copy so that you get used to the way that you're going to do in the exam. Sir, can you please also stream permutation and combination as soon as but I've covered in all of permutation. Combination, I'm in the process of covering. There's one introductory video, another video will be out most likely tomorrow. So I'll do a stream later on. Sir, walaikum salam, I sent you a DM today. Okay, I haven't gone through all my DMs. I'll see. I already have a website, वैसे, and app is in the pipeline. It's going to be out very soon. So I'll see if I need anything, but at the moment I don't. Okay. I don't teach S2. Sorry, I don't teach S2. Do you teach in June and July for those appearing in October, November? No, I don't teach in June and July. June and July, I take a break. But you can get a hold of all the material and practice on your own if that's what you want. You can do that. Okay, let's do another question. Let's do another past paper question. And with the help of this past paper question, we're going to learn some very important rules. Here it is. A survey of adults in a certain large town found that 76% of people wore a watch on their left wrist, 15% wore a watch on their right wrist, and 9% did not wear a watch. Okay, so obviously you either wear a watch or you don't. Okay. A random sample of 14 adults was taken, so that means the number of trials are 14. Find the probability that more than 2 adults did not wear a watch. Okay, so what are we interested in? We're interested in not wear a watch. Okay, so that becomes the probability of the fable outcome. So not wearing a watch is the fable outcome. And what's that? That is basically 9%. So 9% becomes P. That means 0.09. And everything else, whether they wear a watch on their left wrist, right wrist, sar pe pehne, tang pe pehne, jahan pe bhi pehne, that becomes your unfable outcome, which is going to be 0.91. Okay, so this is how we classify them into 2 categories. Now, what about R? So notice the question says more than 2. And how many are we selecting? We're selecting 14. So that means it could be 3 people did not wear a watch. It could be 4 people out of the 14 who did not wear a watch. It could be 5 people. It could be 6, could be 7, could be 8, could be 9, could be 10, could be 11, could be 12, could be 13, and could be 14. Out of 14, more than 2 people did not wear a watch. Okay, so let's look at the possibilities. There are so many possibilities. Now, if we work this out, which we can, we'll also get the right answer, but then we will only be able to solve one question in the exam. Why? Because this will take literally forever. It will take too long, and it's not very efficient. Okay, so because it will take too long, therefore not recommended. Now the question is, what is recommended? Okay, not because it's wrong. The question is, what is, it's going to take too long. Okay, so what do we do instead? Sir, will you do log or ln type questions? That's not in P1, that's in AdMath, so I'll do that when I'm streaming AdMaths. Sir, आप आजकल कहाँ पढ़ा रहे हैं? मैं कहीं पे भी नहीं पढ़ा रहा. I'm teaching at home, online. It's my second year that I'm not teaching in any school. And I like it this way. So what should we do instead? Question for you guys. What should we do instead? Instead of finding out, all these possibilities, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 11, 12, 13, 14, that is correct. What would be the opposite of more than 2? The opposite of more than 2 would be lesser than or equal to 2. Okay, opposite of more than 2 would be at most 2. Okay, opposite of more than 2 would be at most 2. अच्छा, अब ज़रा कुछ notes में ना, I want you guys to add a few rules over here. Okay, so I want you guys to add some standard rules in the notes. वैसे you can download all the notes from the website, along not just notes of this chapter, but notes of every chapter are available on the website, except for permutations, combinations, because I'm still in the process of teaching that. So if the question says, let's say the question says at least R. Okay, at least का क्या मतलब होता है? If let's say मैं कहूँ कि in order to get an A or an A star in math, you should get at least 80%. That means you could get 80 or more, you'll end up with an A star. Okay, so at least R basically means the probability that X is greater than or equal to R. Okay, that's what it means. If the question says at most R, or maybe the question says not more than R. So इस बात का क्या मतलब है? इसका मतलब है probability that X is less than R. For example, if I say that when you're coming to class, you can be at most 5 minutes late, okay, or let's say 10 minutes late. That means you have to be, this is going to be lesser than or equal to. Yeah, it's going to be lesser than or equal to. That means the max that you can be late is 10 minutes. Anything less than 10 minutes is acceptable, but anything more than 10 minutes is unacceptable. Okay? Now, then what if the question says more than R or perhaps greater than R? What does that mean? That means probability that X is greater than R. Okay? And last but not the least, if let's say the question says lesser than or perhaps fewer than R. इसका क्या मतलब है? Probability that X is less than R. Okay? But here's what you have to understand. This might seem like common sense, and it is, really. But what you have to understand is this. That at least R का opposite क्या होता है? At least R का opposite होता है lesser than R. Okay, so this is opposite of one another. Okay, so I'll make some room. ये दो एक दूसरे का opposite है. इसी तरह से, if let's say the question says at most R or not more than R, इसका opposite क्या है? इसका opposite ये है. Okay, so these two are basically opposites. So that means if we can't work out one, we'll work out the opposite and subtract it from one. Okay, so that's what we're going to do in this question. Since we can't work out more than 2, instead what we're going to do is we're going to find out the opposite of 2. So what would be the opposite of greater than 2? The opposite of greater than 2 will be probability that X is lesser than or equal to 2. And since the total probability is 1, we're going to subtract that from 1. Okay, so that's what we're going to do. Greater than 2 means 1 minus the probability that it's lesser than or equal to 2. Now, what's the probability that it's lesser than or equal to 2? Let's find out. That would be the probability that X is equal to 0, probability that X is equal to 1, plus the probability that x is equal to 2. Okay, so this is what we need to find out, and then subtract this from 1. So 1 minus, let's find out the probability that 0 people wear a watch. So 14C0 multiplied by the probability of a person chosen at random wearing a watch, which is 0.09 raised to the power of 0, and the probability of person wearing a watch raised to the power of 14, plus 14C1 into 0.09 raised to the power of 1, 0.91 raised to the power of 13, plus 14C2, 0.09 raised to the power of 2, 0.91 raised to the power of 12. तो हमने क्या किया? हमने निकाली probability that one person, nobody wears a watch, one person wears a watch, two people wear a watch. And we subtract that from the total probability. So what we'll get is the probability that more than, okay, no, मैंने उल्टा बोल दिया. We found out the probability that nobody wears a watch and 0 person does not wear a watch, 1 person does not wear a watch, 2 people do not wear a watch. And we subtract that from 1 so that we get the opposite, which is more than 2 adults did not wear a watch. Okay, so if you work this out, let's see what we get. So here also, I'm just going to write down the answer directly to save some time, and I do encourage you to work this out using your calculator, and you will get 0.126. Okay, so make sure that you have a good grip on your calculator if you want to save time in the exam. Okay, if you don't want to end up lose a lot of, if you don't want to lose a lot of time in the exam, make sure that you have a good calculator and you practice doing questions like these in your calculator. Sir, can these concepts be used in advanced? There is no topic where these concepts are tested in advanced. Okay, so there's no such topic where these concepts are tested in advanced. Okay, let's do another question. Here it is. This is question number 4. The probability that New Year's Day is on a Saturday on a randomly chosen year is 1 upon 7. 15 years are chosen randomly, so that means the number of trials are 15. Find the probability that at least 3 of these years have New Year's Day on a Saturday. So the New Year Day being on a Saturday is our favorable outcome, so that's 1 upon 7. That means the unfavorable outcome would naturally be 6 upon 7. Now what about R? So it says at least 3. So that means R is greater than or equal to 3, which means that it could be 3, could be 4, could be 5, could be 6, could be 7. Now we could work this out, but actually no, since it goes all the way to 15, I thought it was 7 days, then it's not recommended. So obviously it's not recommended that you do this. So instead what we're going to do is, instead of finding out the probability that x is equals to 3 plus the probability that x equals to 4 plus ... the probability that x is equal to 15, instead of doing this, we will do 1 minus the probability that x is less than 2. What would be the opposite of at least 3? That would be less than 3. Okay, so the probability of at least 3 would be, opposite of at least 3 would be less than 3. Okay, so I repeat. Probability of at least 3 would be less than 3. And what does less than 3 mean? Less than 3 basically means the probability that x equals to 0 plus the probability that x equals to 1 plus the probability that x equals to 2. Okay? Now what about the probability that x equals to 0? Which means that 0 years have New Year Day on a Saturday. So out of the 15C0, 0 years have a New Year Day on Saturday. And that means all 15 years will have a New Year Day which is not on a Saturday. So we'll raise that to the power of 15. Plus 15C1, 1 upon 7 raised to the power of 1, which means out of the 15 years chosen, 1 year has a New Year Day on Saturday and the remaining 14 years do not have a New Year on Saturday. Plus 15C2, 1 upon 7 raised to the power of 2. So 2 years have a New Year Day chosen on Saturday, and 6 upon 7 raised to the power of 13, which means the remaining 13 years do not have a New Year Day on Saturday. Okay, so we are working out the opposite, which is why we are going to subtract from 1. All right, so if you work this out, now I'll work this out using a calculator so that you guys can also practice alongside. So make a bracket, 15C0, bracket close, 1 upon 7, close the bracket, raise it to the power of 0, bring this to the side, bring the cursor to the side, make another bracket, another fraction, 6 upon 7, raised to the power of 15. Okay, then bring the cursor to the side, plus 15C1 inside a bracket, so 15C1 inside a bracket, make a fraction, write 1 upon 7, bring this to the side, close the bracket, raise it to the power of 1, bring the cursor to the side, make another fraction, write 6 upon 7, raise it to the power of 15 minus 1, which is 14. Okay, bring this to the side, plus, make another bracket, 15C2, close the bracket, open the bracket, make a fraction, 1 upon 7, close the bracket, raise it to the power of 2, bring the cursor to the side, make a fraction, 6 upon 7, close the bracket, raise it to the power of 13. And finally, press the equals to sign. So we're looking at some value, and we're going to do 1 minus answer because we have to find out the opposite. And this, correct to 3 significant figures, is 0.365. There you go. All right, now I'm going to take a few questions. Sir, please live stream on circular measures. I've done a few streams on circular measures already, but I'll do it again, chalo, if you guys want. Look, P3 is a lot harder than mechanics. Mechanics is later practice. Okay, there's no comparison, I think, between P3 and mechanics. Note P3 is definitely harder than mechanics. But, you know, it depends. It depends. If you are more comfortable with mechanics, I understand physics students may feel more comfortable with mechanics. So I think S1 is easier. That's what I would suggest. But physics students or science students naturally have an inclination towards M1. So that's understandable. But I think for a non-science student, S1 is definitely easier. But the playing field becomes level once you learn all the terms that science students are already familiar with. So yeah. Okay. Now the kind of questions that we're going to solve are basically find n students. Okay, so this is a different category where you're not given the number of trials, and that's what you have to find out. So let's do the first part. Let's see what the first part says. A shop sells old videotapes, of which 1 in 15 on average are known to be damaged. So that means we can find out the probability of damaged, which is going to be 1 upon 5. A random sample of 15 tapes is chosen at random or is taken. Find the probability that at most 2 are damaged. So that means the damaged is a favorable outcome. So that's 1 upon 5 or 0.2. And the unfavorable outcome is that it's not damaged, which is going to be 4 upon 5 or simply 0.8. Now, what about R? Okay, what about R? R would be that it says at most 2. Okay, so at most 2 ka kya matlab hai? At most 2 ka matlab hai that R can be 0, 1 or 2. So we have to find out the probability that X is lesser than or equal to 2, which means we can find out the probability that 0 tapes are damaged, the probability that 1 tape is damaged, or the probability that 2 tapes are damaged. That's it. Had it said at least, then we would have done greater than or equal to 2. Asha, sir, you have done, but it's like jumbled up. I can't get it the way you are doing this year with the whole topic in one stream. So please do for circular measures too. Okay. Asha, why did you do 1 minus probability that X is less than 3? Because the question said at least 3. At least 3 means that 3 all the way to 15. So, that means considering all these possibilities. So this will take us forever. So instead, what we can do is we can find out the opposite of this and subtract it from the total probability, which is 1. Okay, so that's why we did what we did. Okay. Now, let's work this out. Let's see what do we get. So the probability that 0 tapes are damaged would be 15C0. The probability that a tape is damaged raised to the power of 0. The probability that a tape is not damaged raised to the power of 15. Plus 15C1, 0.2 raised to the power of 1, 0.8 raised to the power of 14. Plus 15C2, probability that a tape is damaged raised to the power of 2 since we want 2 damaged tapes. 0.8 raised to the power of 13 since we want the remaining 13 to be perfectly all right. Now, let's work this out. Here also, I'll just write down the final answer to save some time, and that would be 0.398. Okay, so that's the answer to the first part. अच्छा, अब इसका part 2 मैं अगले page पे कर रहा हूँ. Okay, so I'm solving part 2 on this page. Pay close attention. Part 2 says, find the smallest value of n if there is a probability of at least 0.85 that a random sample of n tapes contains at least one damaged tape. Now, I would suggest that questions like these, you use the same approach as you do when you know the value of n. Okay, so if you don't know the value of n, don't change your approach, just use your same approach. Sir, can we do some questions of binomial to normal, and why do we choose 30 to switch? So because if the number of trials are more than 30, then it'll be very difficult to use binomial distribution. That is when we convert it to normal distribution. Okay, we'll do that also. Once we're done with normal distribution, we'll do that also. Now here, you don't know n. Okay, but you're still interested in damaged tape, so that means the probability of favorable outcome is 0.2. Okay, and the probability of unfavorable outcome is 0.8. Now the question says that at least one damaged tape. अब at least one damaged tape का क्या मतलब है? That means as far as R is concerned, R could be 1, R could be 2, R could be 3, R could be 4, and we don't really know when to stop because we don't know what n is. Okay, so that means in order to work this out, we'll have to do one probability of x equal to 1, which means one damaged tape, plus the probability of x equal to 2, which means 2 damaged tapes, plus the probability that x equals to 3, which means 3 damaged tapes. And once again, we don't know when to stop because we don't know what n is equal to. So this is what we'll have to do. Now, instead, what's an easier way? Because we don't know when to stop, right? So it's not an approach, it's not a possible approach to begin with. So instead, what we're going to do is, we're going to do 1 minus the probability that x is equal to 0. Okay, notice that's something that we're already given, which is at least 0.85. At least means greater than or equal to. Okay, so at least means greater than or equal to. At least का मतलब हुआ greater than or equal to. Okay, and we were given the probability that there is at least one damaged tape, which is equal to 0.85. Now, at least one damaged tape means 1, 2, 3, 4, or all n damaged tapes. Now, we can't work that out because we don't know what n is. So instead, let's do the opposite. Probability of at least one damaged tape means 1 minus the probability of no damaged tapes. Okay, so the probability that, God forbid, you fail in one subject is equal to 1 minus the probability that you fail in no subjects. Okay, the probability that you fail, God forbid, at least in one subject is equal to 1 minus the probability that you fail in no subjects. Or let's say the probability that Pakistan wins at least one cricket match is equal to 1 minus the probability that Pakistan wins no cricket match. So we're finding out the opposite and subtracting it from 1. Okay, now how do we do probability? How do we find out the probability that there is no damage tape? How do we do that? Here's how we do it. NC0, 0.2 raised to the power of 0, 0.8 raised to the power of n, and this is greater than or equal to 0. Okay, so this is the equation that we now have to solve. ठीक है, so ये मैं working बता देता हूँ कि मैंने क्या किया मैंने. So the question said at least one damaged tape is equal to 1 minus the probability of no damaged tape. That's what we have done. Okay, so the probability of at least one damaged tape is equal to 1 minus the probability of no damaged tape. Okay, so अब NC0, what's that? That's 1. 0.2 raised to the power 0, what's that? That's also 1. Okay, and this is 0.85, by the way. 0.8 raised to the power n, we don't know. So that's 0.8 to the power of n is greater than or equal to 0.85. I'll explain this question again, but first let's solve this. So minus 0.8 to the power n is greater than or equal to 0.85 minus 1, which is going to be 0.15. So minus minus cancel, and when minus and minus cancel, remember the inequality rule, and that is the sign flips. Now, the sign flip basically means that we now have to find out the value of n, which when applied to 0.8, or when 0.8 is raised to that value, it's lesser than or equal to 0.15. Now, here you have two options. One option is that you can use logs, which I don't recommend. The other option is that you can use trial and error. Now, why is logs acceptable? Because you will do logs in P3. So those of you who are giving S1 with P3 will know how to do it. And why is trial and error recommended? Because anyone can do trial and error. Okay, anyone, irrespective of whether you've done logs or not, you can do trial and error. So let's do a bit of trial and error, and I'll show you the working alongside so you can see exactly how it's done. So we want a certain number, which when 0.8 is raised to, we get 0.15 or less. So n equals to 5, does that help? No, that doesn't help. Because we want the answer to be less than or equal to 0.15. Let's try 6, does that help? So 6 also does not help. 7, does that help? Close. Let's skip a few numbers. Let's try maybe 9, 0.8 raised to the power of 9. Okay, 0.8 raised to the power 9 does give the answer, but let's try 8 also, no. So when I raise 0.8 to the power of 9, that is when we get that's the first time we get 0.134, which is lesser than or equal to 0.15. Now notice the question is probably asking us to find out the smallest value. And what's the smallest value? The smallest value is 9. Okay, so since the question, we can plug in other values, we will get the result, but the other values will give us a result which is greater than, and we don't want the result to be greater than, we want the smallest possible value of n. Okay, I'll explain this question again. This is a bit tricky. I'll explain it again. Yeah, for some reason it has hanged. Okay. So it's, you can use ln also, but you can only use ln or logs if you have done it in P3 or if you've done it in advanced. But trial and error is something that everyone can use. Now we'll solve more of these questions, don't worry, but let me first explain this. So let's understand the question. It's very important that we understand this question. It says, find the smallest value of n if there is a probability of at least 0.85 that a random sample of n tapes contain at least one damaged tape. That means if 10 tapes were chosen at random, how would you find out the probability that there is at least one damaged tape? So that could be 1 damaged tape, 2 damaged tape, 3, 4, 5, 6, 7, 8, all the way to 10. But here we don't know the number of tapes that are being chosen. So that means at least one n means that 1 is damaged, 2 is damaged, 3 is damaged, all the way to n. Now, is there a way to work this out? There isn't, because we don't know what n is equal to. But at least एक damage होने का मतलब ये है कि हम ये ज़रूर कर सकते हैं that we find out the opposite of at least 1, which is going to be less than 1, which is basically 0, and we subtract that from the total probability, which is 1. Okay, so remember the example that I gave? The probability that Pakistan wins at least one match is equal to 1 minus the probability that Pakistan wins 0 matches, or less than 1 match, which is basically 0. So हमने क्या किया? हमने कहा कि क्योंकि हम ये एटलीस्ट 1 की probability नहीं निकाल सकते, हम लेकिन ये ज़रूर कर सकते हैं कि हम 0 की probability निकाल लें और उसको 1 में से minus कर लें. So that's what we did. We found out the probability that there are 0 damaged tapes, and we subtracted that from 1, which will give us the same thing, that the probability of at least one damaged tape, which, by the way, the question says is at least 0.85. So this question is confusing if you don't pay attention to it. There are 2 times that the word at least is used. One is to show that the probability is greater than 0.85. The other is to show that we need to consider all possible outcomes from 1 all the way to n. Okay? So, हमने क्या किया? हमने कहा कि चलो 1 minus 0 कर लेते हैं, because that's easier. So what's the probability that there are 0 damaged tapes? That would be NC0, 0.2, which is the probability that the tape is damaged, raised to the power of 0, since we want 0 damaged tapes. 0.8, which is the probability that a tape is damaged, say raised to the power of n. क्यों? क्योंकि अगर n में से zero damaged नहीं है, so that means all of them are actually damaged, and that is 0.85. Okay, so what's this? This is the probability that the tape, at least one tape, is damaged, which is at least 0.85. Now this is the equation that you have to come to, and after this you can solve it like you solve any other inequality. And somebody earlier asked, why did the sign flip? So the sign flipped because we crossed out minus from both sides. That's why the sign flipped. Okay. Now here is another question, once again following the same concept, where we have to find out the value of n. Okay, so this is going to be question number, so this was question number 5, this is question number 6. So I'd like you guys to try the first part while I'm just going to go grab some water. Try the first part, share your answer, and just so you know, it says fair dice, okay, and what's the probability of getting a 1 in a fair dice? That's 1 upon 6. And what's the probability of not getting a 1 in a fair dice? That's 5 upon 6, okay? And at least 1 basically, at least 3 basically means 3 or more than 3. Find the probability, at least 1 basically means 1 or more than 1. Okay, so read the question carefully and solve. I'll be back on my desk in less than a minute. Okay, any luck with the first part? Could you please cover normal distribution? Yeah, I do plan to cover normal distribution. Don't worry. Sir, O-level Ad Math live stream when? Coming week, inshallah. Walaikum assalam. So, here is the solution. So we are interested in getting a 3, the probability of which we've worked out. And 9 fair dice are thrown, so that means n is equal to 9. Okay, and we want to find out the probability of getting at least 1 3, which means x is greater than or equal to 1. Okay, and that means that we need to find out the probability of getting 1 3 plus the probability of getting 2 3s plus the probability of getting 3 3s, and all keep on doing this all the way to the probability of getting all 9 3s. Okay, all 9 3s on the 9 fair dice thrown. Now, this obviously is not recommended. So instead, what we're going to do is we're going to do the opposite, which is 1 minus the probability of x is less than 1. And less than 1 basically means that it's equal to 0. Okay, so what's opposite of at least 1? That's 0. So 1 minus the probability of getting no 3s, that's what we're going to do. So 1 minus, what's the probability of getting no 3s? That would be 9c0. The probability of getting a 3 raised to the power of 0. The probability of not getting a 3 raised to the power of 9. Okay? So this is as good as 1 minus 5 upon 6, the whole thing raised to the power of 9, which is equal to 0.806. No, not 1 minus 0, 1, 2. इसमें ना एक confusion ये है कि वो बोल रहे at least 1, 3. So I understand why you're saying that. हमें 3 चाहिए है. Okay, we want the score should be 3. And the question says at least 1, 3. So that on the 9 fair dice, you should get at least 1, 3. So that means from the 9 fair dice, you should get 1, 3. You can get 2 3s, meaning that you can get 3 on 1 dice, you can get 3 on 2 dice, 3 dice, 4 dice, 5, 6, 7, 8, 9. So we're going to do the opposite, which is 1 minus the probability of x equals to 0. Okay? No O-level stream today, inshallah. This week there will most likely be an O-level stream. Okay. Now, the reason why I've chosen to this question is to solve part 2. Part 2 says, when n fair dice are thrown, the probability of getting at least 1, 3 is greater than 0.9. So now n is equal to n. The probability of favorable outcome, which is basically the probability of getting a 3, is 1 upon 6. Unfavorable outcome is 5 upon 6. And what are we interested in? Let's see what the question says. The question says probability of getting at least 1, 3, which means the probability that x is greater than or equal to 1 is greater than 0.9. Okay. Now, what do we mean when we say probability of x is greater than or equal to 1? Meaning, okay, at least 1, 3. So we know, we saw that earlier, कि ये एक 3 भी हो सकता है, मतलब एक डाइस पे 3 हो, 2 डाइस पे 3 हो, 3 डाइस पे 3 हो, या फिर all 9 of them show a 3. Actually, all n of them. Okay, so that's the difference between this part and the previous part. In the previous part, we knew the number of dice that we were throwing. Here, we don't know the number of dice that we are throwing. So, can we work this out? No, we cannot. We cannot work this out. At least 1 means that 1, 2, 3, 4, 5, all the way to n. Since we don't know what n is, so we can't really work this out. Instead, what we can do is probability of x is greater than or equal to 1 can be 1 minus probability of x equal to 0, which means probability that we get no 3. Okay, so no के 9 dice में से एक भी 3 ना आए, which means we get 0, 3. So 1 minus, what's the probability of getting 0 3s? Not 9 of them, sorry, all n of them. So all n of them give us no 3 at all. So NC0, probability of getting a 3 raised to the power of 0, probability of not getting a 3 raised to the power of n. And what's this equal to? What's the actual probability? The actual probability is greater than 0.9. Okay, so I'll explain it again. The question says that we are now throwing n fair dice. Okay, so n fair dice are thrown. The probability of getting at least 1, 3 is greater than 0.9. That means the probability that x is greater than or equal to 1, which means the probability of getting at least 1, 3 is greater than 0.9. अब n fair dice में at least 1, 3 का क्या मतलब है? That means एक डाइस पे 3 आए, एक डाई पे 3 आए, 2 पे 3 आए, 3 पे 3 आए, या फिर सारे n पे 3 आए. अब because we don't know how many dice we're throwing, we can't work this out. So instead, what we're going to do is we're going to find out the opposite of at least 1. What's the opposite of at least 1? 0. And we're going to subtract that from 1. So getting at least 1, 3 is the same as 1 minus getting no 3. Once again, winning at least 1 match is the same as 1 minus winning no matches. So what's the probability of getting 0 3s or getting no 3s out of n? That would be NC0, 1 upon 6 raised to the power of 0, 5 upon 6, which is probability of not getting a 3 raised to the power of n, since we want all n dice to not give a 3. Okay, so we solve this. This would be 1 minus 5 upon 6 raised to the power of n greater than 0.9. So that means minus 5 upon 6 raised to the power of n is greater than minus 0.1. So minus minus cancel, and in the process, remember, whenever you cancel the minus sign, what happens is that the inequality sign flips. Okay? So what do? Let's work this out. And how do we work this out? We work this out with the help of trial and error. So you make a bracket, you make a fraction, 5 upon 6, close the bracket, and Let's do a bit of trial and error. Let's maybe start with 5. And we want the result to be less than 0.1. So 5 clearly doesn't work. Let's try 7. 7 also doesn't work. Let's try 9. 9 also doesn't work. Let's try. Now, because we're getting closer, so we're not going to skip a value. We're going to try consecutive values. 10 also doesn't work. So let's try something else. Let's try 11. Let's see if 11 works. So 11 also doesn't work, but we're getting close. Let's try 12. So we're getting there. Let's try 13. 13. Now notice the question was asking us to find out the smallest possible value, and the smallest possible value is 13. Okay, now you can show your working by maybe showing in one value or two. Okay, n equals to 12 gave you 0.112, which is not what you want, which is basically not less than 0.1. But when you tried 13, you did get 0.0934, yeah, whatever, which is basically less than 0.1. So that means the final answer is 13. The smallest possible value is 13. I use an iPad Pro. That's what I use. Okay, so here's another question. We'll make this the last question, and I'd like you guys to attempt this. Yeah, you can use the log method, but I don't recommend that. I recommend, because in log method you can't really see the sign changing, so you'll probably end up making an error or something. So I recommend that you use the trial and error method. Okay, solve this. Mechanics stream, inshallah, soon. Very soon, don't worry. Sir, is giving A-level math composite better or one further math and P1? Composite is never a good idea. Unless you're short on time and there's great benefit that you will get by doing composite, फिर तो ठीक है. But otherwise, I think composite is a horrible idea because you just have one shot. When you break it up, you get multiple shots. You technically get three attempts instead of just the one. Why? Because एक, let's say आपने मई जून में दो components दे दिए, grade अच्छा नहीं आया, you can always give it in October, November. Then also grade अच्छा नहीं आया, you can always give it in May, June the following year. But if, let's say, you're giving composite in the second year of A-levels, that's a horrible idea because if you don't get the right grade, you then have to take a gap year. So I don't recommend composite. I think that's a horrible idea. So what's that, sir? O-level surds and similar figures, please. I've done both. I've done both. How many years of past paper should I do for pure and mechanics? Is 5. 5 years is the bare minimum. Okay, now you should keep on solving till you reach a decent score and you can finish the paper in time. That's That's the number. That's the magic number that you're looking for. Okay, so anyone who has solved this question, please let me know. Let me know what your answer is. I will solve it, but let me know what your answer is. Yeah, I think the camera is stuck. Let me fix it. Surds bhi kiya hai beta maine. I did a stream in which I covered surds, I covered recurring decimal to fraction, I covered, what else did I cover? I covered, whoopsie, और मैंने क्या कवर किया था स्ट्रीम में. बहरहाल एक मैंने काफ़ी कॉम्प्रिहेंसिव स्ट्रीम की थी जिसमें मैंने 3-4 टॉपिक्स कवर किए थे. सर्ड्स, रिकरिंग डेसिमल टू फ्रैक्शन, एक्सपोनेंशियल ग्रोथ एंड डीके, आई कवर्ड दैट, एंड there was something else also. Similar figures also. I think I have posted a video in which I've covered similar figures. I'll double check, but I think I have. So, let's solve this question. The probability that Sue completes a Sudoku puzzle correctly is 0.75. Sue attempts n Sudoku puzzles. Find the least value of n for which the probability that she completes all n puzzles correctly is less than 0.06. So, what's the number of trials? Number of trials are n. Okay. What is the probability of favorable outcome? Since we're interested in her completing the puzzle, so that's 0.75. That means naturally the probability of unfavorable outcome becomes 0.25. Okay. Now the question says that least value of n for which she completes all n puzzles correctly. So that means the favorable outcome is actually n. Okay, so the number of favorable outcomes is actually n. So probability that x equals to n, and that is less than 0.06. So the probability that of the n puzzles she attempts, she completes all n of them is 0.06. It's less than 0.06. Now, how do I find out the probability that she completes all n puzzles correctly? So that would be NCN raised multiplied by 0.75, the probability of her completing raised to the power of n, into 0.25 raised to the power of 0. Okay, and what's this equal to? This is equal to 0.06. So this is 1, and we are left with 0.75 raised to the power of n, which is less than 0.06. Now let's do a bit of trial and error. 0.75, let's raise it to the power of maybe 5. Let's see what do we get. Do we get anything that's less than 0.06? Nope, and it's way off. Let's try 8 maybe. So that is equal to 0.1001. So we're getting close. Let's try 9. 0.075, so we're definitely almost there. Let's try 10. So 10 is the smallest value possible of n, where the number that we get is 0.056, which is less than 0.06. Okay, so the answer is n is equals to 10. That's the smallest possible value of n. Okay, Assalamu alaikum sir, just finished my mock and have my finals in 2 months. Would I be able to get a good... It depends on what your level of understanding is. Okay, it depends on what your level of understanding is, so I can't really say I think you know best right now. And depends on what grade you've gotten in mock. I've covered domain and range of functions as well. Okay, I've covered functions, the new concept, the new syllabus of functions. I've covered that recently as well in a stream. Sir, could you quickly explain the basics of probability, please? But it's not possible to explain the basics of probability quickly. It's a lengthy chapter, so that's not possible. So why did you cut 0.25? Because 0.25 is raised to the power of 0, so anything raised to the power of 0 is 1. So this is 1 and this is 1. NC1 is 1. NCN is 1. 0.25 raised to the power of 0 is also 1. So that's how I cut it. O-level stream, inshallah, most likely on Saturday or Sunday. Okay? So let's, I think, solve one more question. And that would be it. But I will do probability. Okay, so if you're asking me for S1 probability, I will do it. Don't worry about it. So this is the last question. And after that, we are done. So it says 80%. So I'll give you guys a few minutes to attempt this question and then I'll solve it. So I'll give you guys maybe 2-3 minutes to solve this. Share your answer with me. I think this is from one of the recent years, 2023 or 2024. And when you're done, do share your answer with me. Sir, you've been looking down for the past few months? Yeah, I'm doing well. Thank you for asking, but I'm doing good, alhamdulillah. Better actually than I was earlier, but thank you for asking. Sir, thank you. Free of cost. You're welcome, Ayan. I appreciate the kind words. Can we give paper of further math AS without? No, that's not possible. That is not possible. I think the prerequisite of further math is P3. So it's not possible. Even if you want to do, you can't do that. Anyway, so let's solve this question. And if before I solve it, anyone would like to share their answer, please do that. Now the question says 80% of the residents in, so I'm just going to call this K, are in favor of a leisure center being built in the town. 20 residents of K are chosen at random and asked in turn whether they are in favor of the leisure center. Find the probability that more than 17 of these residents are in favor. Okay, so that means n is 20, since 20 residents are chosen. The favorable outcome is that people are in favor, the probability of which is 0.8. So naturally, the probability of unfavorable is 0.2. Okay. Now, what are the number of favorable outcomes? The number of favorable outcomes are more than 17. That means probability that f x is greater than or equal to 17 means the probability that x is equal to 17 plus the probability that x is equal to 18 plus the probability that x is equal to 19. That means 19 people are in favor plus the probability that x is equal to 20, which means all 20 of them are in favor. Okay, so let's find out the probability that 17 people are in favor. That would be 20 C17 into 0.8 raised to the power of 17 into 0.2 raised to the power of 3. Then what's the probability that 18 people are in favor? 20 C18, 0.8 raised to the power of 18, 0.2 raised to the power of 2. What's the probability that 19 people are in favor? That would be 20 C 19, 0.8 raised to the power of 19, 0. Now we're running out of room. Let's drag this to the left. 0.2 raised to the power of 1. Then all 20 of them are in favor. That's 0.2, 20C20, 0.8 raised to the power of 20, 0.2 raised to the power of 0. Okay, so that's a lot of working. That's a lot of values to enter in our calculator, and let's do that one by one. So let's make a bracket, 20C. So I'm just going to do it on my physical calculator because it's much easier. So 20C17, 0.8 raised to the power of 17, 0.2 raised to the power of 3. 20C18, 0.8 raised to the power of 18 plus 0.2 squared. 20. Oh yeah, you're right, more than 17. I thought it said at least 17. You're right. So it says more than 17. So that means हमने 17 को consider नहीं करना. Okay, great. Someone's paying attention. So we don't consider this. Okay, who was that? Son Peter John. Thank you for pointing that out. Okay, so I'll just cross out the 20C17 part. Okay. And 20C18, 20C20, 0.8 raised to the power of 20, 0.2 raised to the power of 0. Press the equals to sign, and if you do this correctly, correct to 3 significant figures, you will get 0.206. There you go. That's the answer. All right, so I hope it's clear, and I hope this is all there is as far as binomial distribution is concerned. Now there is a worksheet. Khan also found out. Found out what? Oh yeah, I think you figured that out first. Okay, so good job, Shafiullah. Thank you for pointing that out. Yeah, okay. All right, Shafiullah gets most of the credit, and then whatever is left, Son Peter John can take that. SAT maths, but I don't teach SAT maths. I used to. I'm completely out of touch with what's going on in SAT. So if I do teach SAT, I'll probably do a horrible job. Okay. So anyway, I'm going to stop here. And in the next stream, most likely I will cover geometric distribution. So I'll see you guys in the next stream. Sir, आपकी IGCSE वाली video for cubic sequence. Yeah, it's also applicable for O levels. It's also applicable for O levels. So it's been added in O levels as well. So it's applicable for O levels as well. So I'll stop here. Tomorrow, inshallah, I am streaming. Not tomorrow. Yeah, tomorrow night. Hey, wait. When is that? Kal hai ya pata nahi kab hai bahar. One of these days. Yeah, tomorrow night. Tomorrow night I'm streaming P1 functions. Okay, so P1 functions will probably be doing, I think, composite function. So I did one part. Now it's going to be a continuation of that. Yeah. So kal ka matlab Friday basically. Okay. So not Saturday. Kal ka matlab Friday. I'll be doing functions. Okay, I'll do circular measure also, but I want to cover some important topics first and then the rest. So I will stop here. I'll see you guys inshallah in the next stream. So take care everyone.